Okay, it's Alex here, Victor Kilo 2 Papa Radio Charlie. I'm going to put together a video here on a step-by-step guide on how to change the 110 volt capacitors in the power supply and synthesizer on the Clansman 320 radio. I've looked on YouTube, haven't really been able to find something specifically detailed so that people can follow along and do this. So I've decided to put it together. You ask why? Why do we need to do this? Well, capacitors, especially capacitors that were installed back in 1980s, only have a limited lifetime, and they do fail. And the Achilles heel of these particular sets is the power supply. And more to the point, 110 volts on the power supply. These particular radios have got quite a complex little power supply in them. It's unit 5, by the way, and it produces 3 volts, 6 volts, 12 volts, and 110 volts. And the 110 volts is critical for this radio to operate properly. Not only is the 110 volt value important, but the smoothing of this DC voltage is extremely important, because the radio uses the 110 volts to produce the variable frequency oscillator and also the varicap diodes for the tuning. So once these capacitors have gone or failed in the set, number one, it won't lock. You can't get rid of the lock, what should I say, the no lock screen that you get on the radio when you turn it on, so it'll just scream at you. And secondly, if they're on the way out, you'll get all sorts of wobbling with your audio as the variable frequency oscillator drifts up and down and wobbles all over the place. So it's really important that we get these capacitors in first class condition to keep our Clansman 320 fully operational. So let's just have a bit of a look at what we're talking about here. The Clansman 320 has got two boards as far as the power supply is concerned, and this is just a diagram of one of them. We've got the 12 volt supply here that's produced on the other board, comes up here and goes through this high frequency transformer, and it's oscillated by this transistor. Gives us a very, very high voltage AC on this side, which is rectified through the full diode bridge, and it's filtered through this capacitor C6, and this is one of the capacitors in question that we're going to have to change. Okay, it comes out here and gets regulated in this circuit here, so this regulates it down to the 110 volts, and then once it comes out the other side, it's filtered again by C8, so lots and lots of filtering happening. And these are two of the capacitors that do age and fail. Once it leaves the power supply, it then shoots off to unit 9, which is the synthesizer. And on the synthesizer board, the first port of call for this voltage is yet another two big 10 microfarad capacitors. I think they're about 165 volt rating, that filter it even further. So you can see the extremes that they go to get this 110 volts filtered properly for the radio. So what we're going to do now, we're going to pull the radio apart, have a look at just how we change these capacitors and where they are. So in order to get the radio apart, we need to take all of the screws out of the front and all of the screws out of the back. Okay, I always do the back ones first and take the back off, then I turn it upside down and take all the screws out of the front. Sore fingers, Allen's key, but that's the way it is. This is really important, take note. The front and the back of the radio are keyed together on the turret shaft. Now, whatever position this is in when you pull it apart has to be put back in the same position when you put it back together. The manual suggests that we put it in this position, the first and lowest frequency position, as a reference position. If everybody was to do that, then everybody would not make any mistakes when they pull it apart. So let's just put that now into that position. Notice I'm turning this in a clockwise direction. The little fingers inside the turret can be easily damaged by turning that up in the opposite direction. They should really have a big arrow up here with this direction only. Many fingers in the turret have been damaged by people turning the turret in the wrong direction. Okay, so we've got it on the lowest position there, and we're ready to pull the radio apart. So let's get it apart and resume the video. Okay, we've just pulled the radio apart. First I'd like to just show you the keying that I was talking about between the front and the back. This little key here, semicircle key, fits into the back down in there, just down in there. Okay, so as I said, it's really important to have the turret selection in the same spot when you take it apart as when you put it back together to match up the key. Okay, look, before we get started, let's just have a bit of a squiz around the set. Okay, over here is the manual tuning section of the radio, and here is the turret. And if you ever want to inspect and clean the little fingers on the turret, you just simply take the screws out of here, lift it off, and carefully clean the contacts so you'll see them in there. Over here is the number 3 section of the board of the radio. It's got the variable frequency oscillator in there and all the tuning circuits. We've got a few filters in the top here. Let's have a bit of a look around here. Okay, this is the reference oscillator. I think that's unit 8. That's the one that gives you the 1.75 megahertz to clock the set and run the whole set. That's the master oscillator there. And here we've got unit 5. This is the power supply. This is the one we're going to change the capacitors. And just here we've got the synthesizer, and this is unit 9. And on the top board in here, there's 2 capacitors as well. Okay, so in order to get access to the power supply, you'll notice there's a little cord here, and this little cord is usually tucked down just inside of there. So there's a plug just below there, and this is the plug for the power supply. So the first thing you do is you get yourself a screwdriver in there, and you lift it and just pop out the little plug. Okay, and that's the little plug there for the power supply. Okay, next thing we're going to do, we're going to undo these 2 screws, and we're going to lift off the can off the power supply. We'll pick up the video there. Well, we've got the can off the top. Notice there's 2 more screws. Okay, and you'll see them here. Little screw here and a little screw over there. These are the screws that anchor the power supply onto the chassis. But the interesting thing is, just below those screws, notice there's a tiny little circlip there. See that little circlip? There's one over here on the other one too. So once you get those 2 screws out and you lift the power supply off, you've got to very carefully remove those 2 circlips, and don't lose them, because those circlips there hold the 2 boards together. Remember I said there's 2 boards in the power supply? So what we want to do is lift off the top board and separate it from the bottom board. Depending on how long the interconnecting wires are between board A and B, depends how much access we're going to get to the capacitors. So let's remove that, get those little circlips off, and have a look. Well, we've got the 2 little boards apart, remove the circlips, and if you look, that little capacitor there, C8, that's one of them, and that one there on the other side of that capacitor, that's the other one there I'm tapping with a screwdriver right there. That'll be C6. And when I have a look at the bottom of that board, I'm thinking, by looking at the soldering on the bottom, that those capacitors have never been changed. They're probably still the originals. I see over here the board's had a little bit of history. It's had a repair on it before by the looks. Yeah, it looks like a little transistor in there has been replaced. Okay, so what we're going to do is we're going to get the solder sucker, and we're going to suck the solder off the joints of those capacitors and remove them off the board. There we go. Right, I've removed the 2 capacitors, as you can see, and these are the 2 capacitors that we're going to put in to replace them. Notice they're a little bit bigger in size, but these will fit. And it's the size of these replacements is very, very important. They can't be any bigger than this physically. And if you're interested in all the details on the replacement capacitors, I've got another video up on my channel, specifically designed at at mentioning the sizes of these particulars and the specifications of these particular capacitors that get changed in the 320. So you might want to go to my other video and have a look at that. But I can tell you here that this one here, C6, we're going to replace this one with a 4.7, and the voltage has got to be above the 125 volts. So this is probably a 160 or something like that. Okay, and over here, instead of the 1.7, we're replacing that with the 2.2. They're tiny, a little bit bigger, but physically they will fit, and electrically they match as well. So yeah, I'm going to fit those in to replace these two now. Okay, I've just put them both back in preparation to solder them in. Notice that the polarity is very, very important, of course. Plus on the outside here for this one, and plus on the inside for this one. Be very careful of getting the polarity right on the replacement capacitors. I'm going to turn it over now and I'm going to solder them in place. Okay, new capacitor soldered in place. Yep. And I always I trim off the excess leads with a little pair of nail clippers. Just put them on snip, and there we go. All ready to put it back together again, and it's just the reverse of how we took it apart. So I'm going to put that back on there, put the circlips back on in place, and go from there. When putting the power supply back into place, the first thing I do before I screw it down is I plug in the, using two hands of course, I plug in the plug before I screw it down, just to make sure that the plug's in correctly and it goes in with a nice distinct click. Okay, I've got my power supply back in place, but notice I haven't put the can top back on, because at the end of this exercise I'm going to start the radio up and do a voltage check on the 110 volt supply. So the next thing that we want to do is to remove the can from the synthesizer, and in order to do that, there's 2 screws they've got to come out and 4 nuts. Be careful when you get them off. Tiny little thin washers need to be looked after, so you can replace them back on at the same time. So let's get that done. Right, now that we've got all of the screws and nuts off and the little attaching plate, we've got to get the lid off the can. It fits underneath this seal all the way around, and look, some of them are easy and some of them are very, very tight to get off. What I usually do is I get 2 screwdrivers. I put one in here and I put one in here. Okay, and what I do, using a hand on each screwdriver, I apply pressure to this side and then this side, and I rock it backwards and forwards, and eventually it rocks and it comes off. It's as simple as that. So I'm going to do that now, and I'm going to remove the can. Okay, can's been removed. It took about 2 wiggles from each side and off she popped. Okay, so let's have a look at what we're up against here. If we look down from the top, you'll see there's a clip on the top board, and inside that clip there's 2 electrolytics in there, and they're the 2 that we've got to change. Okay, so in order to get this board off, what we've got to do is we've got to undo the 4 nuts and the little flat washers. Okay, sounds like you got a double C. Anyway, once we get that off, then what we've got to do is we've got to remove the solder on these little posts. I'll just touch one there. There's one there. I think there's 3 down there, and there's another one over there. There's about 5. Where are we? One about there. 5 of these little stalks that join the boards together. So what we're going to do is we're going to desolder those little stalks and gently, ever so gently, just push them out just a little bit, so that we can remove this particular board and clear them. Okay, so we've got to actually lift the top board off. Now look, before I start working in this area of the radio, I'm starting to think static electricity, and my body does generate a lot of static electricity, I've found over the years. So look, precautions for some people are more than others, So what I'll be doing here, laugh as you may, I'll be taking my shoes and socks off and placing my bare feet onto the concrete floor. I may even give it a little bit of a spray of water on the floor as well. So just a precaution that I do, and well, you can either do it or not. It's up to you, but there you go. Okay, here we go. We've just removed the little board. You'll see the 5 little stalks sticking up there. Okay, so let's have a look at the little board. So this is the little board that we've taken off, and the 2 capacitors that we're going to change are these 2. Notice that they're 9 microfarad, 125 volts. Okay, and they've got the plus clearly marked at that end. Okay, now there is a problem getting replacements that fit in that clip. In fact, I've never known anybody that's been able to get the exact replacement capacitor. So what we're going to do, we're going to replace those 2 capacitors with 2 of these. Okay, I'll just say at this point, I have heard of somebody getting 2 capacitors, putting them in series to make up the required value of the same physical size and putting them in like that. But I've got another method where I use these, and I've probably done a dozen of these Clansman 320 synthesizer capacitor changes with this method, and it works very well for me. So yeah, there's a little slight difference in soldering when we put the replacements back in again, but I'll explain that when I get there. So what I'm going to do now, I'm going to desolder these particular capacitors, and I'm going to remove them. Notice the pluses at this end, the little plus symbols there. So let's get those 2 little caps out of there, and we'll go from there. Right, got the 2 little capacitors out of there. There's something here I've got to explain, that when you look on the other side of the board, where we took the capacitors out, this is the negative side of the capacitor. That was there and there. Notice all of this here is all the negative. It's all negative. What we're going to do is we're going to, instead of replacing our terminals into this section here, we're going to bring them through these holes here, and we're just going to solder them onto the negative side at this point here. That way we're going to be able to fit 2 of these PC type capacitors in place of the axials that we took out. So I'm just going to make sure I get my polarities right. I'm going to put those 2 into position so that you can see what I'm doing before I solder them in. Now, the actual physical distance for the clip is very, very tight for these capacitors. And I must warn that if you try and bend the clip too much, it'll snap off. But look, if the clip snaps off, it really probably doesn't matter, because I don't think the extreme vibration that this radio was made for is probably required for what we want to use them for. But anyway, we'll try and get them in there without breaking that clip, that's for sure. Okay, so again, I must stress the positives got to go in there and the negatives through that hole there. One last thing, there's a couple of transistors on the board below. You can see them there, these transistors here on the board below. Got to be careful that the body of these capacitors doesn't foul with those transistors when we put the board back on. So the capacitors have got to occupy this part of the clip here, not the center of the clip, so more or less just at this end of the clip. Okay, so let's get it all in place, and it'll be self-explanatory then. Okay, I bent the leads appropriately, and I forced those 2 to clip into the clip. Notice the clip's quite extended now. I would suggest not using pliers or anything. Fingers are probably the best tool to get those little capacitors in there. They are a tight fit, and they do go click when they go in. Notice I've got the leads bent appropriately, going into the new position. So I'll be just folding these earth ones back onto the earth rail there, and soldering them back onto the earth rail. You can't solder onto the little eye stud there because it's stainless steel. So I'll show you after I solder them. But most importantly here, I mentioned about the fouling of these on the transistors underneath, so I'm just going to place this board back in place and slide it back to where it would go, and you'll notice looking down there, hopefully you can see that. But the I'll make sure you can. It's a bit dark. Oh, there it is. Okay, so notice that they clear the transistors. They just clear the transistors. They don't fail on those transistors there. Okay, let's get it soldered in place. Capacitor's now soldered in. There and there. Have another look on the other side. So the board now is ready to be reassembled. So what I'll do now is I'll get my little stalks and I'll ever so bend them slightly, putting a little bit of inward pressure on the stalks so that when I put the board back in place, they'll be nice and snug in their little holes, ready to be soldered back in place. Okay, got my board back in place. All the little stalks are up through the holes, ready to be soldered back on. But before we solder those on, we tighten up the little nuts to get the pressure down on the board, and that'll give the little stalks a little bit proud, so that we can solder them back in place. Okay, let's get that done. Okay, with all of the little stalks soldered back in place and looked at with a magnifying glass to make sure that they're all right, the next thing to do is to put the can back in place and all the nuts and screws that associate with that. Right, we've got the can cover back on with all the screws, so job's getting close to completion. But now it's time to put my shoes and socks back on. Thought I was joking, didn't you? Okay, so what we're going to do is we're going to power on and we're going to test the power supply now that we've changed the capacitors. So in order to do that, we're going to put the back of the radio back onto the front of the radio, but we're going to leave the carcass off. So it's just going to be a bare radio with the front and back together. Mentioned to you before, yeah, the turret's in the right position. That didn't get disturbed when we did the job. Notice we've got the D connector, the big one there, and there's a couple of small ones down there. They've all got to line up, and there's some lining up posts as well that are going to help us locate the back on properly. It's pretty easy, but just take your time and carefully push it back on. Okay, we're all ready for the test drive. Just so we don't give ourselves a heart attack when we turn it on and it just won't lock, be sure that you move the turret into the position that corresponds to the frequency selecting switches. So I've rotated this one clockwise and dialed up 14 megahertz. So that should be okay. And when I switch her on, we should get a lock. Okay. Okay. Yep, the radio is locking up nicely. Now look, this voltage takes a bit of time to build up and stabilize, and the place to check the voltage for this voltage is right here. That is the 110 volt terminal right there. So I'm just going to pop my little probe onto that, and that should be enough time. You can see it's up around 109 volts there. Okay, now I must admit, when I turned this on, it was down around about 104, which was probably just a tiny little bit low. Okay, so what I did, I adjusted the regulator. Let's have a bit of a look. The regulator here at R11 right there. And if you look very carefully, you can see it just in there. That little potentiometer there in there. And it's possible to get a screwdriver down and make the adjustment. So whilst the probe was on the 110 volt terminal, I adjusted it in a clockwise direction to increase it, and I got it up to 109.6, and I think that's just about close enough for me. Well, there you go, everybody. A step-by-step guide on how to change the capacitors on your 320. Lastly, what I'll do is I'll put the can lid back on and of course bolt it all back together again. Remember, when I pull the back off, I've got to put this back into the original position. So I'm going to go back to the lowest possible position, right, and then I'm going to take the back off put the whole radio back together again, and then put the back on again, and then away I go to line up the little keyway in the back. Okay, everybody, I hope you've enjoyed my in-depth, step-by-step guide on how to change the capacitors in your 320. Feel confident, don't be scared. And when I get this finished, I'll be getting the best portable radio in existence back on the air, and hope to make contact with you all. This is Victor Kilo 2, Papa Radio Charlie, saying 73. Okay, we've got it all back together again, and one last thing I'm going to do, I'm just going to do a power test on the set and see what sort of output I can get out of it. So in order to do that, I'm using my this is my power meter. So I've got the radio connected into a 50 ohm load. There's a little electronic circuit in here that will give me a reading of the RF peak value, voltage value, and from that I can calculate the peak power. It's just voltage squared divided by 50 ohm load. Okay, if you want to know how to make one of these little devices, have a look on my YouTube channel, and I've got it up on the YouTube channel. Okay, so we've got the multimeter turned on. The multimeter turned on. Got the calculator happening here on the phone. Got the radio on 14 megahertz and selected CW wide. I'm going to hit the button. Oh, by the way, I've got it on low power. I'm going to check the low power to start off with. So let's have a bit of a look. Hitting low power. 14.4. Okay, 14.4 peak volts. So I'm going to type in 14.4 times equals divided by 50 equals 4.1 watts. So 4.1 watts on low power. Very good. Okay, moving right along. We'll switch that up to high power and hit her again. Let's see what we got. Oh, settling on about 40.8. Okay, so let's do the calculation. Okay, 40.8 times equals divided by 50. Yeah, 33.3 watts. Okay, so the set's working really well. Really well. I've tested the antenna tuning. It's actually a nice little set, this one. Nice little set. It could find its way onto the market very shortly. Got a lot of these radios, probably too many, but there you go. It's been a pleasure doing this today, and hopefully you people out there have got a little bit of value from it. Thank you very much. This is Victor Kilo 2, Papa Radio Charlie, saying 73. Catch us all on the air. Bye-bye.